A computer is not one thing. It is 13 things working together. If anyone is wrong, the whole machine suffers. Here is every component, what it does, and why it matters. Motherboard, the backbone that connects everything. Nothing in your computer works without the motherboard. It is the large flat circuit board that every single other component plugs into. The CPU sits on it, the RAM slots into it, the GPU connects to it. Storage drives, the power supply, the case fans, all run through the motherboard. Think of it like the road system of a city. The roads do not do the work themselves, but without them, nothing reaches anything else. It sets the limits, which CPU fits, how much RAM the system can hold, how many drives you can connect. This is why choosing the right motherboard matters before buying anything else. The component that sits in its most important slot is the CPU. CPU, the brain of the computer. Every single thing your computer does starts with the CPU. CPU stands for Central Processing Unit. It is a small square chip, physically one of the smallest components in the machine, but despite its size, it is one of the most expensive and powerful parts of the entire computer. When you open an app, click a button, or load a web page, the CPU executes the instructions that make it happen. It does this by processing billions of tiny calculations every second. The speed it does this at is measured in gigahertz, or gigahertz. The more cores a CPU has, the more tasks it handles at the same time. A 4-core CPU processes 4 streams of instructions simultaneously. A 16-core CPU handles 16. But no matter how powerful it is, a CPU generates enormous heat while working. Without the next component, that heat would destroy it in seconds. CPU cooler, the one thing keeping the CPU alive. A CPU running at full load can reach temperatures of 100 degrees Celsius or higher. Without a cooler, it throttles, degrades, and eventually burns out permanently. The CPU cooler sits directly on top of the CPU and pulls heat away before it causes damage. There are 2 types. Air coolers use metal fins and a fan to push hot air away. They are cheaper and reliable for most builds. Liquid coolers, also called AIO coolers, pump water through tubes to a radiator on the case. They handle extreme temperatures better and suit overclocking. Overclocking means running the CPU faster than its default speed, which generates significantly more heat. The better the cooler, the longer the CPU lasts, and the more consistently it performs. The component generating the next most heat sits just a few slots away. RAM, the short-term memory. RAM stands for Random Access Memory. The hard drive holds all your files permanently, but the CPU cannot work directly from the hard drive. It is too slow. So the computer uses RAM as the middle layer. RAM temporarily holds only the data the CPU needs right now, so it can access it almost instantly. Think of the hard drive as a garage full of scattered items. Finding what you need takes time. RAM is the tool bag you carry with you. Smaller, but everything in it is within immediate reach. Here's a real example most people know without realizing it. Every loading screen in a video game exists for one reason. The CPU is moving data from the hard drive into RAM so the game can run smoothly once it starts. When the loading ends, everything needed is already in the tool bag. 8 gigabytes of RAM is the minimum for basic use today. 16 gigabytes handles gaming and everyday tasks comfortably. 32 gigabytes and above is for video editors and heavy multitaskers. But RAM clears completely when the computer turns off. For anything permanent, the machine needs storage. GPU, built for games, now powers everything. The GPU was originally designed to handle one specific task, rendering graphics on a screen. GPU stands for Graphics Processing Unit. Think of it this way. The CPU is the logical thinker. The GPU is the artistic painter. The CPU figures out what needs to happen. The GPU makes it look right on screen. Unlike the CPU, which has a small number of powerful cores, the GPU has thousands of smaller cores. Those cores run thousands of simple tasks at the exact same time. That made it perfect for rendering millions of pixels simultaneously. Then AI researchers realized that training neural networks requires the exact same kind of parallel processing. Overnight, GPUs became the backbone of modern AI. Some CPUs come with what is called an iGPU, integrated graphics built directly into the processor. It is cheaper and works for everyday tasks and light gaming. But for heavy gaming, video editing, or AI work, a dedicated GPU is needed. The iGPU shares the CPU's power and cannot match a standalone card. It is also the most power-hungry component in the machine. which makes the next part more critical than most people realize. HDD, the original storage. HDD stands for hard disk drive. When your computer shows the warning, running low on storage space, that is your hard drive talking. It holds everything: the operating system, your apps, your photos, your videos. Inside it, a physical spinning magnetic disk stores the data. A small arm moves across it to read and write information, exactly like a record player needle. Because of those moving parts, HDDs are significantly slower than modern alternatives. They are also more fragile. A hard knock while the drive is spinning can cause data loss. So why do they still exist? Price per gigabyte. An HDD stores the same amount of data for a fraction of the cost of an SSD. For large files that do not need fast access, backups, raw archives, old documents, HDDs remain practical. But for anything requiring speed, they were replaced by something that changed computing overnight: SSD. The upgrade that changed everything. SSD stands for solid-state drive. Unlike an HDD, an SSD has no moving parts. It stores data on flash memory chips, the same technology in a USB drive, but much faster. Because there is no spinning disk or moving arm, the SSD reads and writes data almost instantly. A computer booting from an HDD might take 60 seconds. The same computer with an SSD boots in under 10. Apps open instantly. Files load immediately. The experience feels completely different. There are two main types of SSD connection. SATA SSDs use the same cable as HDDs and are faster, but have speed limits. NVMe SSDs plug directly into the motherboard and are up to 7 times faster than SATA. NVMe is the current standard for performance builds, but none of the storage matters without reliable power. Power supply unit, the most underrated component. The PSU, or power supply unit, converts the alternating current from your wall outlet into direct current that the components can use. Every component draws power through it: the CPU, the GPU, the storage, the fans. All of them run on PSU power. One thing most people do not know: laptops have a PSU too. It is the brick in your charging cable. That brick does the same conversion job, then the battery stores what is left over. And yet in desktop builds, most people spend the least time thinking about the PSU. That is a mistake. A low-quality PSU delivers inconsistent power, causing crashes, instability, and in worst cases, component damage. PSUs are rated in watts, which shows how much total power they can deliver. A gaming PC with a powerful GPU typically needs between 650 and 850 watts. PSUs also carry efficiency ratings like 80 plus bronze, gold, or platinum. A higher rating means less energy is wasted as heat, which reduces electricity costs over time. But the case around everything determines whether the heat those components generate can actually escape. PC case. Airflow controls lifespan. The case is not just a box that holds the components. It controls how air moves through the system. Hot air needs to exit, cool air needs to enter. Without a clear airflow path, heat builds up and every component runs hotter than it should. Running hot does not break components immediately. It degrades them gradually over months and years, shortening lifespan significantly. Cases come in 3 main sizes. Full tower cases fit large motherboards and multiple cooling systems with the best airflow. Mid-tower cases fit most standard builds and are the most common choice. Mini ITX cases are compact but require careful heat management in a tight space. A good case is measured not by how it looks, but by how well it moves air. The components that actually create that airflow are next. Case fans, the difference between 5 years and 10 years. Case fans push air through the system to keep temperatures low. They are the simplest component in a PC and one of the most important for long-term health. Most cases come with some fans pre-installed, but the default setup is often not enough for a high-performance build. The standard configuration is intake fans at the front pulling cool air in, and exhaust fans at the rear and top pushing hot air out. This creates a clear airflow path, keeping temperatures stable across every component. Larger fans like 140 mm move more air at lower RPM and make less noise. Smaller fans like 80 mm spin faster, but are louder to move the same volume of air. Most builds use several large slow fans rather than a few small fast ones. Once airflow is handled, the machine needs a way to communicate with the outside world. Network card and Wi-Fi card. How the computer talks to the world. Every modern computer connects to the internet through either a wired or wireless connection. Wired connections use an Ethernet port, which most motherboards already include built in. Ethernet is faster, more stable, and lower latency than Wi-Fi, the better choice for gaming and video calls. Wireless connections require a Wi-Fi card. Most modern motherboards include Wi-Fi built in, but older or budget boards often do not. In those cases, a standalone card slots into the motherboard. Wi-Fi 5 handles most everyday tasks well. Wi-Fi 6 is faster and handles more devices with less interference. Wi-Fi 6E adds a 6 GHz band that is faster and less congested in busy environments. For most people, the Ethernet port is all they need. The next component, however, most people stopped needing entirely. Sound card. Who still needs one? Every motherboard includes basic onboard audio. For everyday listening through speakers or standard headphones, it is perfectly adequate. A dedicated sound card processes audio independently, providing cleaner output with less electrical interference from the rest of the system. This matters for professional audio work, music production, recording, mixing, podcast editing. In those environments, the tiny interference that onboard audio produces is audible and unacceptable. For everyone else, a quality external USB audio interface achieves the same result without using an internal slot. Most people do not need a dedicated sound card. The final component on this list was once essential and is now almost completely gone. Optical drive, the component nobody noticed leaving. An optical drive reads and writes data from CDs, DVDs, and Blu-ray discs. Through the 1990s and 2000s, it was essential. Software was sold on discs. Movies came on DVDs. Music came on CDs. Every computer included one by default. Then streaming arrived. Then digital downloads. Then USB drives replaced installation discs. Optical drives disappeared from laptops first, then from most desktops. Today, almost no PC case includes one as standard. You can still buy an external USB optical drive for around $30. Most people never will. The optical drive did not fail. It was made obsolete by everything around it moving forward. Each component on this list exists because something before it was no longer enough. Now that you know what every component does, the CPU section above was just the start. If you want to understand exactly how a CPU processes information from the inside out, that video is on screen right now.